Okay, Assalamualaikum and salam sejahtera everyone. Good morning. I hope everyone is staying healthy. Vaccines are coming soon. We hope for efficient implementation throughout the country so that we can all somewhat in a certain degree go back to the previous norms. I hope it's not too late to wish selamat berpuasa to those who are fasting. Time flies. It's already 1/3 of the fasting month. So we'll reach Hari Raya Adil Fitri very soon. Hopefully we can all keep adhering to the SOPs to keep the risk in check. Okay, so today HFEM Engineering Special Interest Group or Engineering SIG is proud to organize a webinar as part of our initiative to share the knowledge to the practitioners and to the public. Special thanks to Puan Sabrina and Puan Hajar from HFEM administration team for their contributions in making this webinar a reality. Okay, so let me start by introducing myself. My name is Dr. Radin Zaid, Radin Umar. I'm from University Technical Malaysia, Melaka. I'm going to be the moderator for today. I'm an associate ergonomist and human factor engineering specialist at Ergolit. And currently, I am the chair of the HFEM Engineering SIG. For those who are not familiar with engineering SIG, we are basically a small group of professionals who share the same interest in the area of engineering application in occupational settings or occupational ergonomics. Our core activities in the SIG involve knowledge sharing, research and development, and also we do a bit of industrial engagements related to engineering application in the area of in the field of occupational ergonomics. So going back to the webinar today, our webinar is entitled Major Challenges for Human Factors Engineering or HFE in Oil and Gas Facility. We have today our esteemed speaker, Mr. Muhammad Hafizul Hilmi, Muhammad Noor, from Technip Energies. He has years of experiences in this oil and gas sector, and he would like to share some of those experiences to all of us. Hopefully, we can all benefit from this sharing session. So without further ado, I pass the floor to Mr. Hafizul.
Hello, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Thank you for participate in this webinar. To share screen. Let me share my screen first. Can you see my screen? Boleh? Boleh nampak?
Yes, boleh nampak.
Nampak.
Yeah.
Alright. Okay. Right. Today we will have a 1-hour webinar titled Major Challenge for HFE Implementation. So I thank you for the invitation from HFEM, and thank you for the participants today. Based on the participants list, I found that we have quite a wide range of the profession. From industry, we have from engineering managers up to the trainee engineers, and from academic sector, we have from senior lecturer to the students. Even students we have with us today. So I'll try to adjust my presentation to make it as general as possible, so that everyone can take benefit of it. So I don't want to go that it too deep to these topics, but we give a general overview on these topics. So today we will talk about the major challenge for HFE implementation. I think this is the most important part, major challenge for HFE implementation. But I have to put it in the context of the oil and gas industry because that's my background. Yes. Okay. About me, my background is mechanical engineering. I do masters in engineering science. My professional experience is mechanical and material handling and HFE in oil and gas consultants. So I'm from Technip Energies. It used to be a Technip FMC, but now we changed to Technip Energies. And I have delivered projects in FEED and detailed design for Tronas, Shell, ConocoPhillips, Murphy, Petrobras, and Qatargas. So that's a little bit experience that I will share with you guys today. Okay, what we will discuss today, basically in the maybe less than 1 hours, we will try to recap what is human factors because in the title of the webinar, I put HFE. So hopefully the participants who uh, register for this webinar understand what is HFE, which is human factors engineering. So I try to recap back what is human factors. And we'll try to cover the HFE design principles, HFE strategies in project, and human factors in design. So basically, I'll divide into two, human factors in design and human factors in safety critical tasks. But I'm not sure whether we have enough time to cover the last topics, which is human factors in safety critical tasks, because it's a very huge topics to discuss. Maybe we can cover up to the human factors in design, and later we can arrange another session for the last topics. But if we have time, I will cover a little bit about the last topics. Okay. So along the presentation, I will share the major challenge based on the slides I prepared for you guys. Okay. So what is human factor? This is a definition by IEA, but I hate to start with this kind of definitions because it's on words. But I would like to start with a simple situation. How do we understand human factor? This is a toilet door, maybe at our home, and with a switch, lighting switch, and we have a laundry basket there. That's the common arrangement in the house, in most of our house. Okay, that's the design of the lighting switch. So one day, maybe during this webinar, our kids, our children, want to wash their hands in the toilet and ask us to switch on the light. So because we focus on the webinar or maybe other work, so we cannot attend to our kids. And so let's say our kids is around 5 years old, which is normally these 5 years old kids understand how to use the toilet. So they understand to use the lighting switch and they can use the toilet by themselves. So they try to, because we are too busy, and then they try to switch on the light. Suddenly, unfortunately, the height of the 5 years old maybe I think less than 1 meter, so they cannot reach the lighting switch. But there is a laundry basket there, so maybe the kids try to rotate the basket and climb up and try to switch on the light. But unfortunately, the basket is or break or jatuh, and then our kids fall down and get injured. The question is, when that happens, what is our first question? Let's say we ask them, why did you do that? Of course, they want to switch on the light and use the toilet. But the second question that we can ask is, why it's happened? Why it's happened? Why our kids climb up on the basket and switch on the light and suddenly the basket fall and get injured? So the question is the mischoice or mistake or error or this kind of accidents, is it caused by human itself, or is it caused by the arrangement that we provide uh, at this area? So let's say what option we have. Let's say we remove the basket. So our kids, maybe they can collect basket from other place, or maybe there is no basket there, so they cannot switch on the light. That's fine. That means we just block the possible potential action from our kids. So we eliminate the headers, we eliminate the basket. But second option is we can substitute with other safe tool, which is our kids can step up on this and switch on the light and use the toilet safely. Okay, that's one we substitute, but let's say we use another methods to avoid these accidents. We use engineering control, which is we lower down a bit the switch, because the standard room or standard design in Malaysia is we put the switch is at 1.5 meter height. That's the common design we practice. Okay, but suddenly we try to reduce, let's say, up to 1.1 meter, which is our kids, 5 years old, can reach the light, the switch, and use the toilet safely. So and we do another things. We change the design of the switch, which is this is a new design. So we our kids can easily touch or use that the switch without extra effort compared to the old one. We use this for years, right? So what we can learn from here is our kids can use the toilet and switch lighting switch safely by we changing the arrangement of the lighting switch. I mean, we change the design. So what we can learn here is when we change the design of the facility, we can change how human take action, and we can improve the safety of for our kids in our house. So that's human factor. When we design something that can influence the human, so that design become a factor to the human. So that's why we call a human factor, right? Um, okay, that's a very simple analogy to understand human factor. So if we go back to the definition by the IEA, so there's a combination of knowledge to apply theories and principle, but end up is to optimize human well-being and system performance. So it's exactly what we did for this toilet switch. Okay, and at the same time, when we lower down this, first our kids can use that safely, and secondly, we design for the disabled person, uh, use a wheelchair and so on, especially in a public area. So that's human factors, means factors that affect human performance, right? So what we gain from this modification, we have decreased the human error or decreased the accidents, or in the wider concept, we decrease the occupational injury in workplace, and we increase the safety and health, we increase the comforts of the users, in work performance, human reliability and productivity, which is cover a broad scope of the workplace design. So that's human factors. Okay. The question is, with these facilities, how we are going to consider these human factors? This is FPSO Libra. We designed this for Brazil water and fabricated in Singapore. This is one of the we call it FPSO. So we classify this as complex processing facilities. But within these facilities, there's a lot of components, not only the lighting switch, but we have a lot of components that build this FPSO. For example, we have this is the structural system. for the overall top size of the FPSO. So you can see all the components of the structure. But at the same time, within the same place, we have a piping system, which is transport all the waters, to transport the gas and oil within the FPSO. So this is the actual piping system within this FPSO. You can see how complicated it is. At the same time, we have a mechanical system. There's a lot of mechanical component or mechanical equipment to storage or to process, to generate power, to generate water, HVAC equipment. Okay. At the same time, we have electrical. We need to transfer the power and make this live in the facility. So there's a lot of electrical cables goes around in there. And this is a material handling system for maintenance and operations. Within the same place, we want to integrate the material handling system within the FPSO. So all the system create this complete FPSO. So that's why we call it. And at the same time, during the operation, people will operate this facility, will live there, maybe up to 20 years. Will operate and maintain these facilities and involve a human interaction with all the systems. So we call it a complex socio-technical system, which is at the same time we need to address the human factors concerned in the design. So how we are going to implement this. Okay. So with this complex system, it involves a lot of other factors. For example, we have equipment, we have organization, we have environment, tasks and procedures, and people itself. So all these components have a detailed items there. For example, equipment, we talk about technology, we talk about the layout of the equipment, and HMI. For example, tasks, we need to operate the equipment, we need to do inspection, calibration, and we need to maintain around the 20 years. And we need to do a material handling to replace any component in the system. So all these components will influence our behavior or human behavior or action or inaction of human throughout the lifetime of the facilities. Because we need to perceive any signals, for example, alarm signals. We need to understand what the alarms give the informations, and we need to process, and we need to decide what to do, and we need to take action. And this activities, this process is happens every day, every seconds, after up to the 20 years of the lifetime of the facilities. So I put there the behavior is karena because it's come from the Arabic words, which is korina, which is what we can see in the surface. So behavior is something that we can see from surface, but behind that behavior, there is a lot of a process, cognitive process happens, especially in terms of decision making and action taking. So all these components in these facilities, complex facilities, will play a role to influence the human behavior or human action and inaction. So, so basically, this component is applicable to the oil and gas industry, especially. But I would say it's also applicable to other facilities. Later, we will share what other facilities is applicable for these factors. Okay, so when we design all this equipment and tasks, normally we cover the HFE design principles. These general principles that normally, at least from our company, apply to design this facility. So first of all, we need to check the accessibility. Accessibility means not only to access that items or equipment, but accessibility means we need to design something that accessible by the range of people. Low people, tall people, short people, or in this case, disabled people is not, maybe it's not in the facilities, but we need to consider the man workers, woman workers, and all the different characteristic of the human. Okay, affordability. Can we operate the items? If can, how to operate the items or the bulk? Maintainability. Do we design to ease the maintenance? If we want to take out one component, do we need to take out the whole equipment to the onshore, or we just open one or two bolts and then we can take out smaller components to maintain? And communication labeling, I know this is a very common. Environment, we need to take care whether this area is exposed to thermal hazards or noise, excessive noise, or there is a vibration there. So you need to consider this. And safety hazards, I think this cover the slip, trip, or fall hazards working at high and working in confined space. So when we design this, we need to consider all these factors. And the last one I put material handling because this is for me it's very important in HFE design. One of the crucial parts within the facility. Later, I will focus specific topics on the material handling, what we do in the offshore and oil and gas facility. Okay. So when we design the equipment, when we design the tasks, when we design the procedures or environment, we will consider all these design principles. We integrate everything in the facility. Okay. So what are the complex systems that share the same concept with the oil and gas? It could be pump oil plantation, process of palm oil and so on, because it's involve a process line, manufacturing plant, oil refinery, of course, a nuclear plant, healthcare, OT is operation theater. This is very important because when you involve a very precise operation, for example, because I have the experience with my daughter. My daughter has a heart disease. So when we went to IJN for the operations, we are given opportunities to enter the operation theater, which is the very complex operation theater in IJN for the heart surgery. So I can see with my eyes how advanced the facilities and the setup of the OT for the precise heart operation. So a lot of human factors that involved. In fact, a lot of stories we heard from the IGN, failed operation or a human error during operation that caused the heart bleeding and so on. Okay, military base, of course, airport and control towers. We have Captain Kanadia. I think he's expert on this airport and control towers HFE things. And the railway system, for example, MRT or LRT system, is involve a lot of human machine interface. Okay, and building. So when we see building, we see just a box like this. This is someone called T-Rex Tower or Exchange 101 Tower, which is located at I think near, of course, nearby my office, Technip. So we can see how they construct from the basement up to the top of the tower. So what I want to say is this building is actually a complex system which is involved a lot of human factors. For example, this building has a firefighting system, water supply system, a black water system. In fact, if you see the documentaries for the towers, for the water supply system, they will have an intermediate tank in the middle because it's too high, so they need to pump the water from the ground to this middle level. There is a tank here, if you see. Of course, there is a motor and other components to pump back the water up to the top level. So all this system, firefighting system and evacuation system for the high rise, and how they design to make sure everyone goes smooth. So it's involved a lot of human factors there, even though we see just bots like this. So I would say this is also complex facilities that we need to consider properly on the human factors uh, engineering. But I'm not aware how this construction industry works on the HFE integration. Maybe our friend, uh, others experts can share how they consider the human factors or maintainability of this building. But luckily, this building is on the onshore, so they can employ any facilities to accommodate the maintenance. But offshore is a different story. All right. This is engineering design stage in oil and gas. So I believe our participant from oil and gas industry understand this flow. But for other industries, I believe they have their own design stage. Basically, almost same. Maybe they apply the same concept, which is start with conceptual select, or we call it select from some of the client call it select, but some of client call it conceptual. And we move to front end, which is a defined stage, and we go to detailed design, construction, and operation. So for the HFE implementation, so there is a lot of activities there, but we need to align with the purpose of each phase. For example, during front end, what is the purpose of this phase during design stage? They want to study the technology, to explore the availability of the technology. They want to finalize the size of the platform or finalize the weight of the platform and to try to come up with the cost estimation to develop this facility. And after they finalize that, then they go to detailed design and produce drawing and construction. So due to the different purpose of each stage, so from HFE point of view, also we have a different strategies to cater the HFE scope of each stages. So for example, in the feed stage, we don't do the very detailed analysis. We just do the screening or do some VCA, or if there is information, we do the task requirement analysis for several equipment. Because certain activities will determine the weight, additional weight. We need additional platform or additional facility, additional equipment, and it's add to the weight of the facility and cost of the facility. And during detail design, we will cover quite a detailed exercise and analysis to understand the human factor risk. Okay, so goes up to operation phase. But this detail, I think before this we have the webinar about this engineering design stage for HFE implementation delivered by Dr. Adil himself. So during that time, I think he already explained very detailed about this stage by stage HFE implementation. So I just cover the very brief one. Okay, so we try to look into human factors in design and what is the challenge along the design process. I try to share this uh, very simple item that we try to improve in terms of HFE for ergonomics. This is a foot waist chute design. So normally there is a living quarters there. So in the living quarters there is a galley, which is like a canteen for the workers. So some facility they got around 150% on board. So there is a food waste every day. Food waste. So normally food waste they will dump to the sea for the fish, and later they will fishing that fish. They give the food and they will get back the fish. So this the first photos. That's what I discover in the earlier stage of the 3D model, which is I think this is quite weird. This is not good for ergonomics or body posture when people dump the food waste into this chute. So So just a general understanding, this chute will have like a column goes to the sea, and you just throw any food waste through this column. Okay. So so this structure is under structural discipline. So what I did is I contact the structural discipline. So they say this is not finalized yet. Means there is a possibility that I can suggest a better design considering the ergonomics factors. So I assess the common design from previous project. If you see, I write the design process flow. This is common engineering practice or engineering principles, and it's actually aligned with the iterative process that normally we practice in the HFE. So, but I don't know how operators or workers dump their food, what basket they use, what dustbin they use. So I remember my brother is a chef in the offshore. So he worked in the JDA platform. So I contact him and try to get any inputs how they normally dump the food waste in this food waste tube. So my brother share one photos. It's slightly different design, but you can see the yellow one. This is the yellow. They call it a food waste tube, and the height is more than 1 meter. Of course, I think it's around our waist or maybe around 1.1 meter. And this is the dustbin that they use to bring all the food waste and dump into this food waste tube. So I asked my brother, how you normally do? They will lift this bin. It's quite heavy bin with all the food waste, and turn the bin and dump into this food waste tube. So this is not, for me, this is not good practice, and a lot of effort you need to put to do this, and it's a daily basis or maybe twice daily, because you eat in offshore you eat 6 times a day, so the galley is running 24 hours, and there's a lot of food waste there. And then what we can do, we try to explore several design concepts, because we already understand how they what standard waste bins they use, and how the task sequence they do for this activity. So we try to develop several concepts to improve the design. So if you can see the number 3, this is the first concept that is not happen, and second number 4 is one of our friends happens to suggest this better design. And after we discuss, we do the design review, and we finalize the design component, that we come up with the 3D model like this, which there is a door to avoid people fall down, and it's slightly lower, and you have a round bar to support the bin load, and you can dump to this food waste tube with less effort and safer. So that's the final design. We generate engineering drawing and construct these items. Of course, there is we can argue the design, but as long for us, we can justify this is a good design. We have designed the task properly to mitigate the ergonomics risk. Okay, that's a very simple example how the design process happens.
Nampak tak ibu tengah
During the engineering design phase. So for this simple tools or simple items, we can design with input from my brother. But let's say there is no inputs from the person who do this job, and it's very tough to justify the design. Okay. We go to the a little bit complicated design, which is a piping system design. So normally there is several steps when they design the process piping system. Normally they will start with span ID, or before that they have a PFD, process flow diagram, which is very general one. So later they detail up in the PAN ID. PAN ID is a process and instrument diagram. So in the PAN ID, I can show the development of the piping. The PAN ID is very simple. There is a one line here, and there is a valve. From there, we can identify the type of valve and whether it's normally closed or normally open valve. And there is a PSV there. So during this PAN ID, what we do from HFE point of view, we do the valve criticality analysis. We do the valve category. We categorize the valve according to the C1, C2, or C3 valve, or category 1, category 2, category 3, depending on the criticality of the valve. So normally if a manual valve, standard valve, we put a C2, and critical valve like a shutdown valve, we put C1, that's for example. And from there, we determine the accessibility requirement, whether we need a proper platform or we can operate from the ladder, right? At the same time, we propose a design recommendation. If the valve need to put CSO, they call it car seal open, or maybe there is a discussion to change the type of valve from manual valve to the motorized valve because of the operation requirement. And after that, from the PAN ID, they will transfer the 3D model. So during the 3D model, what we do is from HFE point of view, we will try to we will do the design verification. Okay, we will review the pipe routing, the location of the valve, it's either accessible or not, and the orientation of the lever or hand wheel. And there is another item is safety critical elements that we found during previous projects. It's very critical, very important one. But this is along the discussion about the safety critical elements in the piping system. Okay, after that, they will have a stress. This is not a stress mental illness. This is a stress analysis. So we do the stress on the piping design, whether it can take the sufficient load or pressure from the inside the pipe. And after that, they will move to the isometric drawing. So at this level, from a HFE point of view, we cannot do anything, as far as I understand. So at this level, based on what we finalized in the 3D model, they will transfer to isometric drawing. And they move to construction. It's construction verification. So they will construct, and we will do the construction verification at site. And if required, we do the modification from HFE point of view. So this is the standard procedure, how they are going to design the pipe. And if we see one line, it's a very simple one, but we are talking about the thousands line in the facilities. So the challenge there is how HFE can cope or intervene through this the process. Okay, and end up when they do the construction, if you can see the line, it's exactly like the 3D model. But at the same time, there is a cable tray, there is an instrument pole, there is a structural. So we need to consider all this in the 3D model design verification. So we need to take care of the space, availability to access the valve and to climb up the ladder. So, all right. This is a piping, which is, we can say, when we see from the one line perspective, we can say it's straightforward, but when we combine for the whole facilities, it's quite complicated exercise, and we need a proper HFE intervention. Okay, all right. So another system design that I want to share from HFE point of view. This is I found that the HFE practitioners rarely discuss about this. But for me, this is very one of the most important system in the facility, because throughout the lifetime, let's say 20 years or 25 years, there is a lot of maintenance activities there. So we need to replace component, we need to change the filters or change the membrane tubes. So we need to provide the system to help operators or workers do their job. So material handling is basically is move the components from one point to another points by lifting or lowering, transferring, pushing, pulling, hoisting, and transportation between one to another points. So there is the main components in the systems, which is the first one is laydown area. If you can see, the laydown area normally accessible by crane, and there is a handling routes. When you want to transfer from one point to another, we need to design the handling routes with sufficient capacity to cater the weight of the components. And we have a hatch opening, storage area, there is a crane. This is the main component that we need to design for this operation. And permanent mesh equipment, for example, the monorail, we provide a permanent monorail. And temporary mesh equipment, this is a trolley or David, portable David, and A-frame, so on. And manual handling, of course, that's the most important one, the manual handling parts. Okay, so when we design this, everything is related to human, because to move there, to move here, it's involve human efforts. It's either how we are going to reduce the requirement of human effort, so we provide a better system to help the workers. So there's a lot of very complicated discussion here, how we design this, how we sizing the crane to cater all the components, and how we set up the task design. For example, the first step, what is second step, and what the third step, and where we want to transfer this item. And we need to consider for all equipment. So for example, this equipment, these facilities, if you see these facilities contains more than 150 types of equipment, from the gas turbine to the small motors. So even though it looks small, but this is around 100-meter length and 70-meter width, and the height is around 70 meters as well. Okay, so we designed this to accommodate the human limitation and capabilities. But it's a lot, involve a lot of engineering exercise here. Some for Technip Energies, we have a dedicated person to do this. All this 3D model design is done by one person from our team, based on the lifting studies and all the engineering studies. Okay. So what I want to say is, when we talk about HFE, this is one of the main components that we need to design to have the workers do their job efficiently and safe. Okay, and there is a challenge there, because if you see these items, maybe it's up to 10-ton weight. It's like a container trailer weight, but we need to handle within this platform. So there's a lot of challenge here. Okay, but we can talk this in detail in the separate session. Okay, so here the challenge. I think this is major challenge for HFE. After I explain about the several sample, how we do the HFE studies and how we implement the HFE strategies for the simple items, or for the the piping system and the metal handling system. So this is the overall, when we look at the overall design process as a whole system, we have a multiple disciplines here, which is work in different teams, but they dump all this equipment or items within the same facility. For example, this is just an indication. This is not the actual schedule or Gantt chart. For example, M1 is months, first month, second month, third month, up to fifth month, for example, and final design. Each discipline works in different schedule, of course, because they release the specification at the first month, and then they will contact the leaders and develop the design of the equipment, and they delivers in different months. Same for the structural electrical instruments, HVAC and technical safety. They work in different schedule and different. But we have a single, we have a common milestone, which is a 60% model review. Let's say I put a fifth month. And after the 60% model review, normally we do the HFE design verification. We play around with the 3D model and we see whether the 3D model is comply with the HFE requirements or not. So there is a 90% model review, but the problem is when other disciplines put their items at a later stage. So the HFE review is happen fifth month, for example, but they put at the 14th month, and nobody review that design. So whatever you have agreed during the earlier stage is gone during the 14 months because everyone just put the items at the middle of the accessway and they block the material handling routes. And there is a lot of clash and nobody take care until the end of the towards the end of the projects. But the final design want to ensure the HFE compliance. So how to manage this very for me is considered a major challenge in terms of HFE implementation, especially when we engage, for example, a third-party consultant for the HFE. So we need a proper strategies, not only to cover the 60% or 90% only. In fact, we need to cover up to the end of the project execution. Okay, because everything, a lot of things can happen here. I will put into detail after this. Okay, okay. I put a lot of things happens between HFE design verification and 90% model review. In fact, during this stage, there is still a lot of process design change. There is a new requirement or new operation needs or new area required or new equipment. So there is still additional items after the HFE design verification. So when we do this exercise, the question is it matured enough, the facilities design? So we cannot avoid that. Okay. So during this period, there is a VDI, vendor data incorporation, means any equipment we buy from vendor. So along this period, they will finalize their design and incorporate in our 3D model. An additional item at later stage is very common. We found in the projects at later stage. Suddenly, we have a instrument junction box or distribution box DB, and a lot of cable tray coming in at the later stage. There is a buffer tank or pipe supports come in later stage. Very important one. So they will come later stage without notifying HFE, of course, and notifying other disciplines. So this is kind of a challenge we face during the project execution. Field engineering coordination, work in silo. This is very common practice. Everyone just want to get their job done and leave it like that without considering the accessibility and maintainability of the items. Okay, so I put that technically excellent but operationally failed. So all discipline TikTok, they design the instrument system, they can transmit the information and come back the feedback to the operators. Very smooth systems, but when we come to the accessibility or maintenance requirement, then it's get a problem there. Okay, after 90% and going to the construction. So this another challenge that we normally face during the project execution. There is a difference between the 90% model and the construction. Is of course there is a discrepancies between the actual construction and our 3D model. But how much we deviate from 3D model, that's very we don't have, as far as I'm concerned, we don't have any model to explain how much deviation or different between these two stages. And of course, after construction, let's say for during the design, we consider some space to access, but during construction, there is no space. Okay, that's one of the challenge we face during the project execution. So we need to modify at later stage, or we need to remove some items or remove back the ladder, for example, and then we cut and we install back. It's time consuming and cost. Okay, so if you familiar with this, you can see where the challenge comes in. All right. So this is the example. Our countries shocked a little bit last time because of this issue. This is the first design they did. So they just hit the pillars and just do like this. It's very simple situation, a very simple problem. But after we go through the social media, Facebook and Twitter and Instagram, so we come up with this solution. So is this a new design process? I don't know, just a question. But this is what happened in the common facilities. So we waste a lot of resources here, a lot of costs and workers, and most important is safety of the roads become longer. So we don't want this kind of practice through the social media. So we need a proper integration to complete the project. Okay, this is another example. If you aware, this is a KLI2. This is KLIA1. If you are aware that the what I call it, it's not escalator, travelator, right? It's slightly higher than the walkway. This is a weird design compared to the KLIA because the embed in the floor, so the level is same. Why this happen? Is it because this come later after they encounter the problems or challenge, or it's already in the design, which is not a good design? Okay. Of course, we know the airport, especially the KLIA2, is have a long walking distance with the heavy luggage and the rushing mode in the airports. So this travelator is give benefit to disabled person, pregnant, elders, and children. But I don't know it's come based or it's already based on the actual design. But the good design is like this. It's already considered during the first stage of the project, so they can embed in the same level with the floor without this ramp. So this ramp is very dangerous if you use the wheelchair, and they put the barrier here. So if you have a wheelchair or anything for a disabled person, you need to go through the standard walkway. And because of this, they need to introduce the what they call buggy system, which is very dangerous because they run the buggy through the same accessway with the walking area. So that's I'm not sure how they consider the human factors in this international gates of our country, but the problem is there. So, okay, all right. Okay. I think this is the second part I want to share. Along the design process, there's a lot of involvement by engineers and designers, and of course the HFE team. We have HFE teams to review the model and to give suggestion to the designers how to improve the accessibility of the design. But actually, how HFE people thinks and how designers thinks, and how they their ability to design according to the human needs. So I share one. This is a model created by Maslow. This is they call it hierarchy of needs. So Maslow created this around 1943, which is more than 70 years, or maybe 80 years ago. But a lot of debates on this Maslow's model because they don't have the empirical data to support this model, but it's widely used in different perspectives. And one guy from the Stephen Dudley on the 2010 or 2010, he's a web developer, web designer. So he just come up with this design hierarchy of needs. So normally when we design something, we start with functionality, and we go to reliability and usability, proficiency and creativity. So I have faced a lot of experience with the designers that they will focus on their design things, which is they ensure the take care of the functionality and the reliability of the equipment. For example, they design the pressure vessels, so they ensure the pressure vessel is functional according to the process requirement, and reliable means can sustain the containment and the pressure or temperature. But when it comes to usability, nobody take care. So they just provide the nozzle at high point. So if no one requests the platform, that's it. No platform to access that. So that's the HFE coming into the picture. We take care on the usability when you put the valve or instrument. We need to put in the correct area or correct location, so that is accessible. And proficiency is upper than the usability. Maybe we need to design for better performance or avoid the human error. And the creativity, which is a higher level, how to simplify the things and how to make things interesting and then with the arts touch. So so that's what I see. Designers will focus on this reliability, but HFE will focus on the upper level. But the challenge is how we are going to educate the designers or engineers to at least take care of the usability parts. And at the same time, we want the HFE persons understand the functionality and reliability of the equipment, so that we know when we want to intervene the HFE requirement. Okay. So designers, when they design, they need to design right in the first place. So they need to consider usability. So I think this area is a gray area. Some of the designers is very understand the usability requirement, but some of them is still focused on the technical parts, which is the functionality and the reliability. So the proper seminars or training should be done to close this gap or to blend this barrier. Right. Okay. When we want to design something, I always ask to myself: do I really understand human characteristics, capabilities, and limitation, or can I anticipate how humans perceive or process information, make decision, and take action? This is a challenge to the designers and challenge to the HFE practitioners as well, because we don't remember all these details. For example, anthropometric data. Maybe we know the average height of the Malaysian. Some study said 1.68, and the highest is 1.79. We know that, but how about the detail? when we want to apply in the design. Okay, in the oil and gas, we have this kind of standard. Okay? There is a lot of standard that we can apply. For example, there's the famous one. The first one is HFEM. This provide a very extensive design specification so that we can apply in the equipment or facility design. So there's a lot of standards there, including if you do the Shell project, you have the DEP, and if you do the Petronas projects, you have a PTS. Okay, and in fact, the Dodge got the guidelines for manual handling at place. But there is a certain area. Sorry, before that, from these standards, okay, we can generate the HFE specs. So this is one of our projects. We generate this poster for to ease a designer to consider all these requirements. So basically, this is based on the Petronas specs, and we get the additional requirement from the STM. So it's easy. Designer can follow the requirement. In fact, there is a case that they don't follow, but when we want to verify the design, we will use this standard reference. But there is a case where there is one designer come to us. They said we don't have the space. We just have 600, but we need a 750. Okay. So how to solve this? They come to us. Sorry, our time is until what time? Ready?
Until 11, but I think we can extend a little bit, a few more minutes, a few more times.
Okay. Yeah. I think if you guys have other things to do, because it's a Saturday morning, so you can leave early. But I will continue a little bit, maybe at another 10 minutes. Is it okay? The Zoom okay?
Yeah, sure.
The Zoom is not.
Zoom okay. Zoom tak ada masalah. No problem.
So come back to this. Even though we have very nice design specification, but there is certain cases where the designers or engineers come to us, say we don't have this piece, and HFE teams will see the design or see the 3D model on drawings. We will ask whether can we rotate this or can we shift this a bit and then change to the different design. They say cannot. That's another problem. They say cannot. So how to solve this problem? Can we deviate from this HFE specs, or can we trade off with another design or another components or another ideas? So that's kind of a challenge that we face during the project execution, and end up they will ask HFE opinion whether the current design with insufficient space to access or other HFE problems can be approved or cannot. So what to do? So this is a kind of issues that we need a special assessment from HFE team or HFE specialist. And this has happened along the project execution from day one to the construction phase. They will always come to HFE to ask the recommendation or approval of the deviation of this design specification. And from HFE team, what HFE team can do instead of approve the non-compliance design. Yeah, that's kind of challenge we always face in the project execution. Okay. All right. This is one example that we face in the projects. So this happened after the equipment already fabricated and installed and ready to ship next week. Okay. So they show these photos to us, and from first sight, I think there's a problem from a shipping point of view. So the problem is in terms of affordance. If you're familiar with these words, affordance, So this control buttons allow us to hold, because there is a the holder there, and same stack they need to twist to the trip or to close options. But the problem is the label puts push to operate. So from first sight, we identify this problem because we understand the principle of the design and how people react to this design. Okay. So what really happened actually? If you see this, how do we operate the control button? This is actually we call it the mental model for us because we're already familiar with all types of the button design. So once we see, we know how to push or we know how to pull, or is it required to twist or toggle switch, how to operate, or joystick, how to operate. And there is a slide switch or fingerprint or flick. Okay, there's a lot of options to control the buttons. But on this case, when we further investigate with the vendor, they say you need to push and then you need to twist. Okay, now the label push to operate. So maybe this is not the emergency button or critical button, even there is a circuit breaker control. But if it's a critical buttons and people push and nothing happens, so this is not good design. So what to do? Let's from a HFE point of view, what we can recommend to them. We cannot change the design of the handle, this button. What we can do is we update the label, push and rotate to operate. So at least they can take the correct action to operate the control. Okay. So if the designers or HFE practitioners don't have this awareness or the understanding of the design principles, so this kind of problem we will not address during the engineering design or construction phase. Okay, so the bad design will bring to the offshore and operate for 2 years. So we don't know what happened during the operation phase. Okay, so the design principles behind these buttons is twist control and push control. So if you see the standard design, this button, once we see this button, we know this button is designed for twist control. Same as per this button, when we see for the first time, we know this button is for push. So means in the design, there is a principles that apply to the design that give us the understanding or discover how to take the action, either twist or push. So the combination of these designs normally apply to the safety critical items. For example, if you see the kitchen hook, is combination of 2 or more design principles for the specific purpose. Okay, so this is for safety critical. When you want to operate this, we need to push and rotate. So when you see how they design it, it just gives us the idea how to operate this. So there is a gap there for push, and there's handle for twist. That's how we apply the design principles to the facilities. Okay, so this is another example. Emergency stop button. The first photos you see, they put immer stop. I don't know what is immer. Of course, we are already familiar with this this equipment, so we know this is emergency stop. But what happened to other people that don't understand these shortened words? Okay. So they put like this. They cover. They need to cover the stop buttons, but they cover with the flat metal, which is we cannot see at the first place. So the label is wrong and we cannot see the first place. So during the emergency, where is the stop button? We cannot find it. Okay. And there is a sharp edge. So normally this design, This design, they give us the idea to bump by our hands. So if you design like this, sharp edge, you will have a mark on this hand, 2 marks here. And when you open, you cannot see the emergency stop label. So it's very, for me, it's not a good design, and we can improve any further. Okay. All right. So this is the universal design principles that we need to understand, especially for the HFE practitioners and for the HFE safety persons and designers, if they can understand this. There's a lot of universal design principles we can apply in the oil and gas facilities design. As long as we understand what we want person to act, or how we want to change the behavior of the workers. So there's affordance, consistency, mapping, accessibility, and all these you can. There's one book, very good books. I believe most of us are already familiar with these books. It's changed the perspective on the design. So this is by the Don Onman. This book is published, I think it's more than 50 years ago, but it's still relevant to us, including the oil and gas practitioners or other industries designers, to apply these design principles. But there's other items. If you see Fitts law, Gutenberg diagram, all these, there's another good books you can explore, which is a universal principle of design. So in this book, you have more than 100 design principles that you can apply when you propose a design to the oil and gas facilities. Okay. Although a lot of principles there is applied to the graphic design or the product design, but some of it you can apply in the facility design, like oil and gas platform. But how to apply then, for example, how to apply the mapping, constraint, or feedback, or colors, that one we need to discuss further in other session, because it's quite complicated, because this design principles is related to how human perceive, how human process the informations and take action. So it's more to psychology topics. Okay. Yeah, there's another books what I can recommend to the designers or practitioners. 100 things every designers need to know about people. So from this understanding, we can apply to the facility design. Because what we concern is when we design the facility. For example, for this button, end up we are play with the safety critical tasks. When people cannot find the correct button or find the correct area to work or to take action, and there is a potential possibilities that accident can happen or accident can escalate to catastrophe. Okay, so I think I want to stop there. It's a long presentation already, 1 hour. So because from here, actually, it should jump to the human factors in the safety critical task. But this, like I said before, this is a very broad topics that we can discuss in a separate session. Okay. All right. With that, I end my presentations. Or maybe you have a few questions that we can discuss today. I give back to Dr. Radin.
All right. Thank you very much, Mr. Hafizul, for your presentation. I'm sure that all of us can take some take-home points from the session just now. Unfortunately, we don't have much time left. Sebab kata pepatah, masa mencemburui kita. However, I'd like to open for short question and answer session to the floor. We actually have few questions in the chat room. So, Mr. Hafizul, if you can go over to the chat room, you can select few questions from the participants to answer.
Okay, let me go through the chatbots. The first one is, what is the rule of thumb for providing permanent structural mobile stack based on assessing frequency? Okay. There is a rule of thumb to provide the permanent or removable stairs. In the oil and gas, actually, based on my experience, the only factors that we can use to determine whether we can put a permanent or movable stair is VCA, which is a buff criticality analysis. It's all about the assessing the buff. So there is a C1 buff or C2 buff or C3 buff. C1, of course, we need a permanent platform, these stairs. C2 buff, some projects, they need a permanent platform with ladder, vertical ladder. Some clients accept to use the portable platform. But if you base on SSA frequencies, industry call for 6 months. 6 months is the baseline for the whether you consider frequent or not frequent. Means if you need to assess once it's 6 months, means it's become the required permanent platform. And if less than 6 months, we can opt for mobile platform. So that's the baseline in the industry. But why 6 months? That's a big question to me as well, because we can always argue with this subjective guidelines. I still don't find the basis for 6 months, but in the industry practice, we just use this basis as a best practice for across the industries. Dr. Jalaluddin is my mentor. Quick access, frequent, and impact if access cannot be achieved on time. Yes, that's the when did we do the PCA? So there's a very simple rule of thumb for me. If you need to access frequently, maintain frequently, maintain space or replace frequently, that's considered frequent, and we can take a 6 months as a basis. Okay, Dr. Jalal already answered that question, so I think that's enough. Yeah, recommendation by designers are not in. Yeah, I think that's a very good answers from Dr. Jalal. So I don't want to add anything there. It's sufficient to address the questions. Does cost of the design have same weight as compared to other design criteria? Does cost of the design? What do you mean, Hazel? This is our friend from Philippines. Does cost of the weight. Same weight as compared. Oh,
Yeah, I think it's about the cost itself. Does it have any weightage? So you have like many options. Does the cost of the design have the same weightage, or does it have like a different weightage? It's the things that have if the cost of the design is. I think when you're selecting
the decision making.
Yeah, I think so. That's what I'm interpreting here.
Means if you want to improve the HFE requirements, then maybe some items will add another cost to that projects. So does cost will influence the decision to improve the HFE. Okay. I have one experience related to cost. For example, because we have two different stage of the projects. We have a fit and we have a design. Sorry, a detailed design. So the basis of the cost for the project is based on the fit study. So when they finalize the fit and they finalize the cost and they bring to the detailed design, so they ask us to work the detailed design within the same cost that they have finalized in the FID, final investment decision. And during the detailed design, we have to work within the scope. That's another challenge. If you want to add platform, for example, that involve additional cost or additional weight to what has been agreed during FIT, so some of the parties will reject this kind of recommendations. Same as well if related to control center. So if during FIT they have established that the control center should be designed according to this ISO 11064, this ergonomics, right? So when they do the costing, they have to consider all these requirements in the ISO. All right. So during the detailed design, when they want to add anything that related to ISO, they have to absorb the cost. So it's but if we suggest anything that beyond this requirement for ISO, or maybe the client standards, just consider additional items, or special design of the chairs, or special design of the tools to eliminate the HFE risk. We will compare back to the what we have agreed in the scope, especially during FITs. If consider additional costs, and there is a possibility that projects will reject our proposal with additional costs, unless this additional cost or cost factor can be agreed with the client, so that they can pay additional cost to this project because of the HFE risk that we identified during detail design. I think that's why I can respond to this. Yeah. If you want to discuss further on this item, I think we can always communicate, maybe through email or through LinkedIn.
Okay, Mr. Hafizul, actually, Mr. Shahrul Othman already asked this question earlier. Maybe if you can respond to him. Can you share the experience on designing HFE aspect for control room? I think this one is also related to what you mentioned earlier about ISO.
Okay, yeah, control room is very complicated facilities in the offshore. But when we go to practical, when they want to prepare the specs for these chairs or desks, they will state the ergonomics chairs only. Okay, we don't design the chairs during the works. It's very detailed one because we design the whole control room and the whole platform. But if you see how we design the chairs, specific chairs for the 24/7 hours, practically we don't do that in detail. I mean, review the chairs and to add any what components that can accommodate the 24/7 hours workers. But what they normally do, contractor do, is they specify the ergonomic chairs and they try to find the suitable chairs in the market. So they will float the specification and the requirement, and within the certain cost, and then they will find it in the market, and they will select based on the what we recommend. So from there, the HFE practitioners can intervene, especially during the selection of the chair design. So, but we don't design that specific chair. We just get from the existing market and we buy that chair. So if you say there is a requirement for 24/7 hours, we need to do that, on the chair, there is no such thing in the design process, as far as I experience, based on my experience. Okay, any other questions? I missed the top one. How to overcome human factors. Early HF intervention, actually, in the point of redesign and the budget is very important. So procurement. Okay, we just come back from the site verification for one of the projects. First of all, the rule of thumb is we will try as much as possible cover the HFE requirement during the design stage. So once you go to the construction, the schedule of construction is very tight and very messy. when you go to the verification and a lot of workers there, and you have to give them the space to do their job. I think Dr. Jalal and others, Aiza and all the teams have this experience before. So there is a certain area that we can comment during the construction and commissioning, but of course the construction will hate us. Will hate us because they don't want to modify anything. We want to keep progressing additional items, additional component to be installed. Because for example, the sail away date is next month. So they need to make that. So if you come and say you need to remove this structure and change to another structure with another design that require engineering drawings, so this kind of practice is not good actually, and people will not like it. So how to overcome? We need to discuss the acceptance. Okay, normally in the presentation during the construction, I separate into two strategies. During the engineering, I call it offensive strategies. We can change the design during the design stage. We can add anything in the scope, and we can change the drawings during design stage. But during construction, we apply the defensive mode. Defensive mean for me, we try to convince client to accept whatever we have. Okay, as long as we can justify in terms of accessibility. If not, if there is if it's a deviate a lot of from the HFE specs, of course we need to punch. We call it we raise a punch list to do the modification. And we do have a from the last site verification, I raised 30 action items. Some of it just to demonstrate the usability of it, or some of it you need to open back, cut the steel and then shorten the steel, or make it higher the steel, or add another steel on the facility. So of course it's involve cost, involve extra manpower and impact the schedule, but we need to accommodate that design to mitigate the HFEs. Okay. Slide akan diberi. Kita akan tengok nanti yang mana yang boleh bagi, yang mana yang keep confidential. Okay, I think I have addressed all the questions. Ada lagi ke?
Okay, ada anyone from the floor? Maybe we can do have one or two more questions, if any.
Yeah, I should thank to Dr. Jalal for the giving the feedback on the questions. Dr. Jalal is one of our established HFE specialists in our country. Done a lot of projects across all the clients, and that's my mentor actually. Okay, so if there is no more questions, I thank you for the participation, and you can reach me through the email and LinkedIn. I open for discussion, or maybe you have a different opinion, please share with me so that we can align the best practice in the industry. But don't ask for job vacancy. We don't have for now. All right, thank you.
Okay, thank you, Cik Muhammad Hafizul. Just to add in just a little bit regarding the questions about the chair, because I also have encountered this question before on the chair. Actually, we have to differentiate between ergonomic standard specifications and also the quality chair standards, because there are two different things. If you are talking about the chair are being utilized 24/7 and tend to degrade fast, so that one usually revolves around the standards of in terms of the quality. The ergonomics usually revolves in terms of the adjustability, in terms of the range of the how you can accommodate the design according to the user's requirement. But there's also a different design, for example, from BIFMA, for example, as a standard that looks into the quality of a chair. Because a chair can be ergonomics, it can be highly adjustable, but it's not a quality chair, meaning that you can use it for 2 months and then it breaks down. So there are
Yeah.
a few standards on that. Just to add in lah, because
Yeah.
I have
Maybe
encountered that question before.
maybe I can add. So normally the contractor has a range of vendors or model to propose to client based on their previous experience. But along the process, normally client will feedback the existing chairs that they already bought for the other facilities, and they will maybe recommend other brand, a quality brand to purchase. So contractor need to consider that recommendation or request from company, and if it's within the cost allocation, and they just purchase the high quality chairs. But if it's very special design and beyond the current allocated budget, and they need to raise additional cost or whatnot. That's the common engineering practice in the oil and gas. Okay, I think that's it from me.
Okay. All right. Okay, I'd like to wrap up today's session with a huge thanks to our speaker, Mr. Hafizul Hilmi, for sharing his experience to all of us. I hope his sharing can help us understand the main principles and components in HFE, especially in the complex context of oil and gas sector. But hopefully we can also take the basic point that Mr. Hafizul shared and apply in our own respective fields. So thank you everyone for your attention, for your dedication, for staying until the end of the session. I hope to see all of you again in our next event. Okay, goodbye and wassalam.
All right, thank you.